Okay, so we're continuing on in our quadratic equations chapter or topic, and in the previous video we just did some revision of expanding brackets and made sure that we were familiar with some of those common expansion patterns, perfect squares, difference of two squares, etc. So today we want to begin to look at factorization, and there's a number of factorization techniques we use depending on what our expression looks like. And today we want to talk about using common factors, which would be reversing the distributive law discussed in the last video, identifying that we have a difference of two squares and using the patterns that we know for those factorizations, and also using a process called grouping, which only works in a sort of limited number of circumstances, but I want to introduce that as a technique here because we're going to use that as a way to be able to factorize non-monic or harder quadratic trinomials in a couple of videos' time. So we'll have a look at that. So in its loosest sense, factorization is the reverse process of expansion, but I just want to elaborate on that a little bit in terms of what it means to factorize. I'm just going to scroll over to the side here. In that some people sort of, or some students sort of get stuck on the idea that if it's got brackets, it's factorized. Okay, if you have an expression that is, let's say, x plus 1 times x minus 3 plus 5, this is not factorized because you've got plus something on the end. You don't just have factors of something. So factors being things that multiply together to produce that answer. So if we think about numbers, for example, let's think about factorizing, I don't know, the number 24. Okay, so we know that 24, and there's lots of different ways we could break it up. 24 might be 4 times 6. That might be how you do it. So that would be, in that case, we have factorized 24 as 4 times 6. But we wouldn't say that 24 is fully factorized because each of 4 and 6 can both be further broken down. Okay, and so, well, 4, that's actually, sorry, not 4, it's actually 2 times 2. And 6 is actually 2 times 3. And so actually, in its simplest, most fully factorized form, 24 is the same as 2 cubed multiplied by 3. Okay. Now, it would be true that we could say that 24 is 2 times 11 plus 2, but the minute it's got a plus here, it's not factorized. That plus 2, 2 is a factor of 24, but that particular plus 2, okay, so let me make it 3 times 7 plus 3. Again, I've created the same problem, haven't I? What about if I do something less than that? Let's say, well, even just let's go with 1 times 17 plus 7. Okay, neither 1 nor 17 is actually a factor, or 1 is, 17 certainly isn't a factor of 24, and the fact that we've got this plus 7 on the end, which also isn't a factor of 24. Okay, you've broken it up, but you haven't factorized it. So it's really important that you understand that it's not just about brackets, it's about only having brackets, because it's actually not about brackets at all. It's about rewriting the expression so that it involves things that are being multiplied together. Okay, so, you know, x times y, that's factorized. That's things multiplied together. X times y plus 5, no, not factorized. X times y plus 5, that's factorized. You're multiplying two things together. Okay, so we want to be able to rewrite the expression so that it is 1, 2, well, not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, infinitely many things being multiplied together. Okay, that's the key when we're trying to factorize, and that's really important as we continue to move through this topic. When we're looking at solving quadratic equations, we want to be able to make use of the fact that we want to factorize and write one side of the equation as things that are being multiplied together, and we'll come back to that down the track. Okay, so let's talk about the options for factorization, some of which we'll discuss in this video, and there'll be 2 further videos on factorization. So the first step in any factorization is always to factor out the highest common factor. That's the thing you want to look at, whether it's a simple linear expression, whether it's a very complicated algebraic expression involving lots and lots of terms. If you are trying to factorize it, the first thing you want to identify is whether there are any common factors. Okay, quite frequently you can make something into a much simpler factorization process by first taking out a common factor. So regardless of how many new methods are introduced to you through this topic, faced with a problem that says factorise, your first thing thinking in your mind should be, is there any common factors here? That's always number one. Then you deal with what you've got after that. Okay, so let's have a think about these examples here. So we're looking to fully factorise. We're going to first try and identify whether we have any common factors. Now, I'm seeing negative in common, definitely. If both terms are negative, we should certainly factor out the negative. 3 is common to both 6 and 15. And there's obviously 1x that's also common. So negative 3x is the highest common factor there. And when we take out, now again, we use that language when we take out negative 3x, what we're really doing is dividing the expression by negative 3x, because we're essentially taking something and writing it as negative 3x times something else. For example, if I told you that 3 is a factor of 24, the way you would find the other factor is to divide 24 by 3. It's the same logic here, okay? Negative 3x is a factor of that algebraic expression. The way to find the other factor is to divide by negative 3x. So negative 6x squared divided by negative 3x leaves me with 2x. And you should be able to check it. If you multiply them back together, does it give me negative 6x squared? And then negative 15x divided by negative 3x is plus 5. And again, you should be able to check it. There's no excuse for having factorization. Factorization's wrong. You should be able to very quickly in your head expand that back out and make sure that it gives you the original expression. Okay, part B. The first thing we want to identify here is any common factors. Now, sorry, I think that's a typo. Let's make that a 2. Any common factors there? So no numbers in common, but we certainly have an x in common here. X, and then we're going to be left with 2x squared minus 3x and plus 8. And then we would want to look to see whether we can factorise this expression any further. I'm going to go on to that in a future video, and actually in this instance, just checking in my head, that wouldn't factorise any further. There are other processes we can use if we're trying to solve an equation, but it doesn't factorise any further. So that is fully factorised. Okay, I want to get into some interesting examples of identifying common factors in these last 3 questions. Now, I know that the instinct of many of you will be to expand out these brackets, and I really want to suggest to you that in the vast majority of instances where there are brackets, expanding them out is very often not a helpful thing to do. You just create more terms that you then end up having to factorise back again anyway. Okay, so again, we're looking for common factors. Now, you might be able to see that this has a common factor of x plus 1. Okay, if you have trouble seeing that, imagine that I say, okay, let's call x plus 1 something. Let's just call that y, for example. So this expression becomes x times y minus 3 times y. And now you should be able to see that y is a common factor, leaving you with x minus 3. And obviously y wasn't, we introduced that to help us, y was x plus 1. So this is x plus 1 times x minus 3, okay? But I want you to try and be able to do that without needing to actually make that substitution. So I really want you to be able to sort of see right from the outset, okay, this bracket is the common factor. Let me take that out. And then when I take that out, what do I have left? I have x minus 3. So when I do x times x plus 1 divided by x plus 1, I'm just left with x. When I do negative 3 times x plus 1 divided by x plus 1, I'm just left with negative 3. And so there it is, fully factorised. Much easier than expanding it out and then having to use our processes for factorising quadratic trinomials, which we'll review over the next 2 videos. Again, second thing, in the next example here, it's not just a single term that's common, it's a bracket. X plus 2 is common to both terms in that equation. So if we take out x plus 2, okay, in the first term, x plus 2 all squared divided by x plus 2 still leaves me with x plus 2. And then in the second term, x times x plus 2 dividing by x plus 2 leaves me with x. And then obviously I want to tidy up that second bracket by collecting like terms, so I've got 2x plus 2. Actually, this presents an interesting situation, because now that we've done that, that second bracket actually isn't fully factorised. There is a common factor in that second bracket now, and that is 2. Now, can we talk about this actually, because this is an interesting process here. So x plus 2, all right, technically it's going to be times 2 times x plus 1. But it's not very neat to write this times 2 in here. Remember, this is 3 things that are all multiplying together. We've talked about that in a previous video. If you're multiplying 3 things together, you can write them in whatever order you want, and it's still the same multiplication. So let's write that times 2 at the front. And we've got 2 times x plus 2 times x plus 1. Okay, don't need to expand out the brackets. This example here, same again. We've got x times x plus 5 minus x plus 5. So it might help you to think of that as being minus 1 lot of x plus 5. So if we take out x plus 5, common factor, and then we're going to be left with x minus 1 when we do that, fully factorised. So here it wasn't factorised, there's brackets involved, but they're subtracting from each other. Here, brackets involved. The key though is that those 2 brackets are being multiplied together. You've now written this expression as things that are multiplying together. Okay, even if those things, individual things, have additional subtraction in them, the whole point is you've essentially got something times something, and later on we might have, more than, and that might be a term, that might be a bracket, it might be a more complicated bracket, okay, might be all sorts of things. But it's got to be things multiplying together to be factorised. And each of those things being multiplied together shouldn't have any further common factors. Like what we saw in part D here, there was a common factor of 2 once we had factorised, and so we then needed to go a step further and take that 2 out. Okay, so it's common factors. Let's recall our difference of 2 squares pattern, and I've really been encouraging you when you're expanding these sorts of things to recognise that it is a difference of 2 squares and be able to go straight to this point. And it's really important that you can recognise these patterns to enable you to go in reverse and recognise, oh, I've got something squared minus something squared. I can use the difference of 2 squares pattern here. Okay, so as I said, we really want to be able to identify it as something squared minus something else squared. Okay, and then the brackets will be the first something, take away the second something, and then the first something plus the second something. Now, this would be the same as having a plus b times a minus b, okay? I'm sorry. Remember, the order you write the brackets in doesn't matter. The order you multiply things in doesn't matter. So you can put the negative in the first bracket or the second bracket, it doesn't matter. That's up to you, okay? All right, so we want to use difference of 2 squares to fully factorise each of the following. So we first need to identify that we have a difference of 2 squares. And again, I probably wouldn't write out these steps, but just while we're learning and just so you can see exactly what's happening, where I'm getting these numbers from, x squared minus 25 is x squared, take away 5 squared. And so therefore, we recognise we've got that difference of 2 squares, and we're going to have x plus 5, x minus 5. And again, you should be able to expand it back out to check. X squared minus 5x plus 5x minus 25. Great. Okay, the second example here, part B. 16 is 4 squared. And then we've got taking away y squared. So we've got a difference, subtraction in the middle, of 2 things that are being squared. And so now we can use our rule. So we've got 4 minus y times 4 plus y. Or you might write that as 4 plus y, 4 minus y. Doesn't matter, it's the same thing. Okay, part C, we need to remember what I said to you not very long ago, that the first step of any factorisation is to look for common factors. Okay, so there's a common factor of 3 happening here. So let's take that out first. 3 times negative 4 minus x, plus x squared. Now, so that we can see that difference of 2 squares, probably nicer to write that as 3 times x squared minus 4. Now, you might have taken out negative 3 at the first step, and then you would have had 4 minus x squared, and then you could have gone from that point. And you have a slightly different looking expression because you've taken, the negative out to the front term. Okay, so now inside the bracket I recognise that I've got a difference of 2 squares, that is x squared minus 2 squared, so x minus 2, x plus 2. Okay, so part D, we've got y squared minus 3. All right, now technically this doesn't factorise any further, but it is possible to factorise this using the difference of 2 squares. But we have to go into the realm of surds to do that, because we would need to think about 3 as being, the square root of 3 all squared. And so therefore it would be possible to write this as y minus root 3 times y plus root 3. But technically speaking, actually, if you have to go into the realm of surds or irrational numbers in order to do the factorisation, we would say that actually y squared minus 3 is it doesn't actually factorise any further. It's possible to write it this way, but you wouldn't need to. We would be happy enough to say that y squared minus 3 is fully factorised as it is. It can't be simplified any further. The other thing I want to note, sorry, I just made a statement there that's slightly incorrect, is that factorised doesn't mean simplified, okay? So you don't have to factorise an answer unless the question explicitly asks you to factorise the answer. Similarly, expanded out isn't more simple than factorised. You don't have to expand the brackets if the question doesn't tell you to expand the brackets. So whether you've written a final answer in factorised form or expanded out, it doesn't matter in terms of it is in simplest form. If the question asks you to factorise an expression or to expand an expression or to write your answer in a certain form, then you need to think about that. But often I see students kind of unnecessarily factorising an answer at the end or unnecessarily expanding brackets out in the end. You're not making your answer any simpler. It's an unnecessary step at the last moment. Okay, E. First thing we want to think about common factors, but there actually aren't any common factors between 9 and 49. 49 is 7 squared and 9 is 3 squared. But they're actually perfect squares, so we should be able to think about 9x squared is the same as 3x all squared. Take away 7 all squared, and so therefore, using our difference of two squares, we get 3x minus 7 times 3x plus 7. Okay, F. Now again, these are problems where I see students love to expand for some reason all of a sudden, and often expanding when it's completely unnecessary to do so. We have a difference of two squares here. We have something squared take away another something squared. And we know from our difference of two squares that we take, when we factorise, we take whatever's in the first whatever's being squared first, we write that at the start of the bracket. Whatever's being squared second, we write that at the end of the bracket. And we put a plus in one bracket and we put a minus in the other bracket. So in this case, we're going to have x minus 2 plus 10, x minus 2 minus 10. Then the next problem I see that students have is where even if they've managed to master this process, they then don't actually go on and simplify the bracket despite there being some like terms that can collect together inside this bracket. So x minus 2 plus 10, negative 2 plus 10 is plus 8, so that is x plus 8. X minus 2 minus 10, this one is x minus 12. And yes, you could get there by expanding out the bracket, collecting all the like terms, and then factorising back the quadratic trinomial, which we'll look at how to do in the next video, but it's completely unnecessary to do so. Okay. All right, again, this bracket here, my apologies, this bracket here, this question here, we could think about this also as a difference of two squares. We've got x plus 1 all squared, so that's a perfect square, take away. And again, like the example up here with y squared minus 3, we'll need to think about 2 as being root 2 all squared. Okay, so then we're going to be able to factorise that. That will be x plus 1 plus root 2 and x plus 1 minus root 2. Now in this instance, we can't collect together 1 plus root 2. It's in its simplest form as 1 plus root 2. So actually we can't simplify that any further, and we are done. All right, and then part H, again, we can see that's already written as a difference of two squares. We've got two things being squared and subtracted from each other. And so we're going to write the first, the thing in the first perfect square at the start of the bracket, the thing in the second perfect square at the end of the bracket. And we're going to write a plus in one bracket and a minus in one bracket. And we're going to need to be really careful about the bracket where we write the minus, because if I want to subtract all of 3x plus 1, it needs to be in a bracket. Okay, you could put brackets around here in the first set of brackets, but actually it doesn't make any difference because, you know, at the sorry, used an enormous eraser. Let me fix that. So what do we have? X plus 2 plus 3x plus 1. Okay, so you could put brackets, but you don't need them. The only place they're really necessary is here at the end here when you're subtracting something that has more than one term. Okay, and again, we don't want to stop at this point. We want to collect all the like terms in the brackets. So we've got x plus 3x, which is 4x, plus 2 plus 1 plus 3 in that first bracket. And in this second bracket, we've got x minus 3x, so that's negative 2x, and 2 minus 1, so plus 1. So you might find it's perfectly fine as it is, but you might find we tend to prefer not to have the negative at the start of the bracket, so we might write this bracket as 1 minus 2x. You also might choose to take negative 1 out, and again, like when we factored out the 2 in the second bracket further up, We wouldn't write it in the middle, we would write it at the front. So you could take out the -1 and instead write that as 2x minus 1 if you prefer. Okay, all of those are the same and all of those are fully factorised. Okay, the third method I want to look at in this video is this idea of factorization by grouping. And as I said, this is a little limited because this won't work every time you have 4 terms, but I want to introduce this process now because it's a key step in the method that I'm going to teach you for factorizing harder quadratic trinomials or non-monic quadratic trinomials. So I just want to introduce this step of that process here. So sometimes expressions involving 4 terms can be factorised by grouping the terms. It doesn't work for all expressions involving 4 terms, but as I said, it's an important step in the process we're going to look at in 2 videos' time. So we want to factorise each of the following by grouping. So what this essentially involves is if you've got 4 terms, you want to focus on grouping 2 to get 2 of those terms together and the other 2 terms together and looking for common factors in those 2 terms. So sometimes that might require reordering your expression. In this instance, things are okay. I'm liking that there's a common factor of a in those first 2 terms, and there's a common factor of 4 in those second 2 terms. So we focus separately on those pairs of terms. So highest common factor in the first 2 terms is a, and that leaves us with 3x minus 1. And then the highest common factor in the second 2 terms is 4. Now I'm going to write what I commonly see on students' papers, 4, and then you're going to get 3x minus 1. Now the problem is happening here. If I don't write a symbol in here, it means multiplication, but we're not multiplying but these we're not multiplying all this together. We've factored out positive 4. This is a times 3x minus 1 plus 4 times 3x minus 1. Make sure that there is a plus or a minus written in here, please. Don't just leave an absence of an operation there. Okay, so now we're looking for our highest common factor, which is this bracket. We looked at examples of that earlier. So 3x minus 1 is a common factor here, and it is being multiplied by a minus 4. And now we have fully factorized 2 things multiplied together. Okay, second example here, we want to look at grouping the terms, and you can shuffle them around if you want, but I'm happy enough here. There's nice common factors between those first 2 terms, 2 and x. Second 2 terms, not so many common factors, but I want to actually use this as a specific example here. So 2 and x are common factors in those first 2 terms. So taking out 2x, we get left with x plus 5. And then, sorry, I think I've got an error in. Sorry, there's an error in the question here. I'm going to make this a minus 5. Actually, no, I'm going to make this a minus 10x instead. Okay, so we factor out 2x and we get x minus 5. Okay, we look at the second 2 terms and there's no common factor there other than 1, okay? But if I wrote this as plus 1 times negative x plus 5, we're going to have a problem where, see what happened at this step in example A, 3a, the bracket needs to be the same in order for us to take it that next step further and fully factorize. So we actually want to have x minus 5 in the bracket. So here, instead of taking out positive 1, we take out negative 1, which will then be negative 1 times x minus 5. And now we've got that common bracket. We factor out that common factor of x minus 5, and we get left with 2x minus 1. Okay, and then part C, we want to use factorizing by grouping. So in its current order, it's not that helpful. There's no common factors between the first 2 terms. There's also no common factors between the second 2 terms. So let's think about rewriting it. And you could do this in a couple of different ways and you would still work. In fact, I might show you that it will still work. I'm going to think about doing AB minus 3B and then plus 2A minus 6. Okay, so remembering that we can reorder the terms. This is a positive AB, a negative 6, a positive 2A, and a negative 3B. You can think about those as 4 building blocks that you can put in any order. So we wanted to reorder them so that now I've got that common factor of B in the first 2 terms and a common factor of 2 in the second 2 terms. So I'm going to have B times A minus 3 plus 2 times A minus 3. And now that bracket of A minus 3 is what's common, and multiplied by b plus 2. Okay, so that would be one way that we could do it. The other way that we could actually reorder this same question would be to perhaps think about instead having ab plus 2a and put the terms with the common factor of a together, which would then leave us with minus 3b minus 6, okay, and group those two terms together. So same expression, I've just ordered it slightly differently. In this case, looking at the first two terms, taking out a common factor of a leaves me with b plus 2. In the second two terms, I can take out that common factor of negative 3, which also leaves me with b plus 2. I've now got that bracket in common, so b plus 2 times a minus 3. So we get to the same point. Okay, so there's no right or wrong way to order the terms in order to be able to group them. So you just want to make sure that you're grouping them in a way that there are common factors, but there could be more than one way to get there, but ultimately it still gets you to the same final answer. Okay, so the work today is from exercise 6b, practicing taking out common factors, including bigger common factors like a whole bracket might be the common factor. We want to look at difference of two squares, again, where your two squared terms might be more complicated expressions. It might not just be x squared minus 9. You know, it might be x plus 2 all squared minus 3x plus 8 all squared. We still can use the difference of two squares to factorize that. We shouldn't need to expand them out. And the third type is this factorization by grouping, which, as I said, is a really important technique to master as we move on looking at some of our other factorization methods.